Here we go. Hi, everyone, and welcome to this Keptn User Group. It's first time in this format, and we are very excited to have a great agenda for today. Since we are trying out this new format, I want to let you know that these meetings are also recorded. We will put those meetings also on our Keptn YouTube channel. Keptn is a CNCF project, so we're also following the CNCF Code of Conduct. That basically means please be nice to each other in the chat and in the Q&A section and in our Keptn community in general. For today, we have a packed agenda, I want to say. And the first agenda item, it's not on the agenda directly, but I would like to ask you, please also put your name on the attendee list so we can keep track a little bit of who is joining our user groups and who is part of the Keptn community. So you all know that we have the Keptn Slack and our Twitter channel, but we also want to establish these meetings and we want to keep track a little bit of who is joining and who actively wants to also to contribute to these meetings. I will then again post the link to this document in the chat so you can also add your name. Well, then before I hand over to Andy and Sumit, I want to start with our Keptn Community Rockstar celebration. And as you might be familiar with our Community Rockstar program, it's really a program where we want to award our Keptn community, outstanding members of the Keptn community that stand out by either integrating Keptn with other tools, by talking Keptn, by giving feedback on Keptn, by testing Keptn. And for this quarter, we have a whole group of community rockstars. And we are very happy to have here Roman, Christian, Artur, Fabian, and I think that's it from TrisCon. So thank you so much for joining and congratulations on the Community Rockstar Award. We are right now in the background preparing the PR that you're also officially named Community Rockstars of Keptn. But I want to briefly hand over maybe to Roman, to you and your team. Maybe you can talk briefly about your success with Keptn and how you're using Keptn and what you did to contribute to Keptn and to receive this award.
Absolutely. Well, first of all, thanks for having us over, and we really appreciate the award. We're happy to be part of such a great community. It's really fun how we all work together. And so who are we? We are basically a company that is fully dedicated to all topics regarding performance engineering. So we do a lot of performance tests, and we had some, say, obstacles to achieve something like an automated quality gate, which is the idea of automating the entire process of performance testing, including the evaluation. And this is where Keptn came into place. We're mostly using Keptn in a combination of toolset. So Keptn Neurload we use for stressing load, but could be anything, and Dynatrace for APM. And Keptn takes over the part where you are able to automate the evaluation, because in load tests, you usually don't only have a pass or fail like in a functional test. There's a lot of things to consider, hundreds of metrics to evaluate, and this is where Keptn is such a great benefit for us. And we're currently establishing this approach also at customer sites in the insurance sector.
Cool. Thank you so much. I just take a quick screenshot because I have every one of you in my Zoom. So in 1, 2, 3. Perfect. Thank you. And I will also use the screenshot for a short tweet. So thanks so much. Yeah, we also we will merge this PR just in a second. Oh, I see it's already merged, so it's also now announced on our community site. In our community rockstars. So now it's very official. Thanks so much again. Congratulations. Hopefully you already received your small thank you swag box from the Keptn team and from everyone from the Keptn community. Thanks so much for
Yes, thank you very much for the shirt. Currently wearing it right now.
Yeah, thank you.
This is great. So thanks so much. Again, for everyone that just joined our Keptn User Group, I will just post a link to this document in a second. Please add your name also on the attendee list. And with this, I'm already handing over to Andy and Sumit, and I'm really excited to hear their story on Keptn with Argo, with Jenkins for distributed load testing.
Exactly. Well, I think, first of all, congrats from my side as well. It's not a rock star, it's a rock band that we kind of celebrate today. And yeah, it's perfect. It was a pleasure so far working with you guys on this, and I'm sure there will be many more success stories coming out. So I'm hoping to see you soon back on the Rockstar board or user groups, webinars, whatever it is.
We'll do our best.
Yeah.
Thanks. We really appreciate it. We
Yeah.
also enjoy working with you a lot. It's really great. Thank you for that.
You deserve it. And this what's interesting is the topic is also a perfect segue to what we will see from Sumit, because Sumit is just as passionate about performance as you are, large scale load testing, and he solved a lot of problems through automation. Keptn is one part of it, but you will see today what he and his team have built is amazing in terms of automating performance testing in a large distributed way. Which means I would actually like to hand over to Sumit, and maybe you can share your screen, and because I know you have some slides prepared and a demo as well. So let's see if this slide sharing works. Perfect.
It works. Thanks a lot, Andy. And congrats to all the rockstar. You make Keptn really feel proud. So let me start on that, and thanks, good segue of calling that performance testing and how we are doing distributed load testing. So we were, I'm principal engineer, part of Intuit reliability engineering platform. And what we have done is already being shared in the open source. And I was chatting with Andy about that, how we can use and leverage Keptn. And we interacted with him around, I think, 6 or 8 months back. And we had one specific challenge on the self-service and the automation. And that is the time we found that Keptn is there. And we integrated that. So this story is about that. But moreover, like, I think this is mainly for anyone who's doing distributed load testing on Kubernetes, how they can leverage and do that. So with that, let me start the session. Let me know if it is viewable.
It's visible. And also, folks, for those that are online watching, if you have any questions, I will play the moderator. And also, Sumit, I may inject with a question or two, because obviously I know your history, because we've been working together over a couple of years, more recently on Keptn. But if questions come in, then I'll also try to, if it makes sense, push it over to you live. Otherwise, we'll have dedicated time at the end.
Cool. Sure, definitely. So this is a little bit about myself. I've been working in Kubernetes from last 3-4 years. Many open source, Kiko, Proj, Argo, Keptn, Litmus. I'm a maintainer and contributor to the Litmus chaos, as well as a lot of contribution to the chaos toolkit. This is, I think, Andy shared that, like, how we are using today. So we are right now using one single cluster, 2 Keptn projects, 50+ services, and most of the services what we have actually onboarded, they are automated way. We have not manually go and automated through Jenkins declarative pipeline. We onboarded that, and we created a dynamic SLO. I will talk a little bit more about that. And then we have various kind of loads. So how we are using Jenkins to switch dynamically based on the load. I will share a few of our code base to go more on that. Now, we do have a lot of automation, but this actually help in do without any manual intervention, end-to-end automation. And this is self-service. So we assume anyone who is able to add the code for their relevant project and service for their SLI, SLO, everything will go handy. They don't need to come and do that. So it's a user base git commit. They make the change, put everything in the git, and then the Jenkins declarative pipeline will pick it up. And we use Argo workflow, which definitely help in the distributed load testing cost. So little bit about my team. I was leading a team of three domain. One is a chaos engineering, the second one is the performance, and then the third one is the infrastructure, where this whole thing is coming. We are doing distributed load testing on chaos as well as performance. I have recently presented on KubeCon where I talked in brief about that chaos workflows and how we are doing. In performance testing and distributed load, we are using the same concept. Actually, we introduced that in performance first, and later we have actually implemented on the chaos. This is about my platform. We have thousands of developers, more than 200 clusters, many namespace, and more than 200 services already onboarded on that.
Hey, and Sumit, just a quick question, if you can quickly go back to this. I have from a chaos engineering perspective, and also Jürgen is working closely with the Litmus team. So we do have a Litmus integration. I know we talked about this. And by the way, people that don't know, you have just yesterday, I think literally just came back from India. You're now back on in the US. And it seems you're juggling a lot of different projects. Chaos engineering, performance engineering, and an amazing platform that your developers use at Intuit. It's amazing what you do, and it's great that you contribute back to open source and even find the time to talk with us about this. This is really cool.
Thanks a lot, Andy. Yeah. In fact, the Keptn and the Litmus Chaos integration, I was when I was presenting in the Litmus Chaos, I actually shared that we are integrated with the Keptn, and that's how this whole communication started. And Karthik and they work with the Keptn community leaders and did that. So this is the place where we come in handy, and this is the overall platform which is helping all our services to onboard and provide the highly scalable, stable solution. So let me just take a step back and let's talk about what is distributed load infrastructure. And I think there are a few folks, they are already there and they might be dealing something or similar to that. So we typically used to have a common Jenkins infrastructure, which is a shared infrastructure through which we usually create the loader, test loader we call. And then you have certain commercial tool also came like the Frontline or something like that, which also help in doing that. But logically speaking, we don't have any dedicated infrastructure which is just running the perf. So we usually be sharing a Jenkins infrastructure, which is doing our build pipeline, functional test, and then it become a very, very messy, because if you run the perf test, it will take longer time. Security is a challenge because anytime you go and interact with that, you probably need to take care of that, how you are interacting with that specific endpoint. Cost is pretty high, and as well as time. Few of the perf tests, they take longer time, and then they hold lot many resources. And there was no natural way of Kubernetes integration. And this challenge, how we have solved is that, so we came up with the problem statement that we need some solution which is scalable, which is a container native, and has to have a self-service, build on the open source tool. So this was the main problem statement when we started on this, and how we achieve at this presentation is all about that. So little bit insight about this distributed load infrastructure, what we are able to do that. IKS stands for Intuit Kubernetes Services Platform, and as we were doing validation of this platform, we started building this infrastructure. So that means that we are eating our own dog food upfront, which later we have shared with our customer, and that there are many teams has actually started using. We recently, I think a month or 2 months back, we are open source also. So it's readily available if anyone wanted to consume on Kubernetes. The second and important part is that a lot of load testing tools, they are not the container native approach. We have a test container, but we really don't have anything which is a container native. Most of the things what we are seeing is that you get the code from Git, or you get the code from some of the other versioning system. You use your one of the load distribution, either Jenkins or Frontline or whichever, or Neoload, and then you go and trigger that. So this is the insight we have. So we really don't have that. And then most of the time you have infra as a code. So right now, if you look for the self-service, you go and modify Git and then you get a trigger. But there is no way you can make those changes dynamically, that I already put a code. Now, just based on the traffic pattern, I increase from 10 TPS to 10,000 TPS, 5 nodes to 50 nodes, something like that is not there. You usually have to go and code. It's not very self-intuitive. And then the cost. If you use any commercial tool as well as any of the Jenkins infrastructure also, it requires a lot of cost. So we use Argo workflow, which is a backbone of this, and that take care of all the resourcing and job related stuff. This is based on the Gatling. Right now it's supporting Gatling, but it supports JMeter also. It is based on the Argo workflow. Right now we are already integrated with Litmus Chaos. Keptn is the one which we are today talking about that. And the DISTRO is the project which already being keeping everything in tandem. And this has a lot of reporting capability. We use Operation Data Lake, we call it the ODL, and then it has a Splunk integration. Last but not least, we have a lot of collaboration and monitoring tool. But what we have done is that we created a paved road so that any new team comes, they onboard to this platform and they get everything out of the box. So we have two use cases. One use case is that any team who has a service or engineer, they wanted to run the test. And the second one is that for us, the platform or SRE team or reliability engineer, we wanted to validate the platform. So to do that, based on the specific need, we made a lot of changes and we got a lot of requirement to make that. So first and foremost is that I should be able to test against any application. It should be self-service. And then I should be able to scale based on my need. I really don't need to come and say that provision this instance, or I need to go and add more virtual users, something like that. I want everything to be dynamic. As long as I have Kubernetes cluster, I have a namespace, I have resources available, I should go through horizontal pod scaling, leaps and bounds, how much I want. And for my team perspective, the security compliance is the one part, as well as the onboarding is the second part, which we really want, because we want others to onboard quickly. So at a very high level, this infrastructure is like everything is in code. So application service code is there, and that will create a service image. Like that, we create a test code also as part of the Git, and we create a test image. And all this work is happening by this infra code, which is tying with the service image as well as the test image. We get all these images like as Docker container images and set it up on one of the namespace. And from those namespace, these test stubs will make a call to the service endpoint. And they push the data through we do have monitoring, and we push the data to the data lake, and we use Amazon S3 because we are heavily rely on AWS. Now, just the same infrastructure, if you go one level down, like how actually it's been realized, it's realized is that like you have application or service code, which is creating a container image, which can be triggered by a Jenkins pipeline and your CI integration functional and performance test. Your test code is also being part of your CI process. So when you build your service code, you build a test container code also, and that test container will also be published. Now this infra code, which we have, this will pick this container, which is a test container, using the Argo YAML based configuration, and it will execute on one of the Kubernetes namespace. Now, to execute anything on the Kubernetes namespace, you need two things. I think I have shared in the DISTRO project that how you can do that. So you need Argo workflow so that you can view that. So Argo UI to view that, and a workflow which actually trigger that stuff. And based on this container, it will spawn off these workflow pods, which is just using this container image. And through Argo workflow account, it will target any of the namespace in the same cluster or outside cluster. So right now we opted both the option. You can have the cluster target the same cluster in a same namespace in a cluster, or you can go outside. And then all this data, because when you are running the distributed load testing, each pod will generate a test and it will create a report. So it's really important that you need to aggregate the report. And to do the aggregation, we have a certain step mentioned. And when I mentioned this funnel, that means that we are aggregating, consolidating, and reporting. So I will show that. So anything if you want to take out from this presentation is this slide, that however everything is being happening. So everything is in code. So we have a Gatling script, which is being checked in the Git. And you have infra code, which is a YAML code, which is nothing but doing what a container, test container. This has been triggered by Jenkins. Jenkins will interact with the Kubernetes cluster by kube context. And this has a very limited permission just to submitting a workflow. Once you submit a workflow, or you submit through cron job, if you don't want to use the Jenkins scheduled one, then what will happen is that the workflow pod will initiate. This workflow pod, once it will initiate, it will do 3 actions. It will just go and create a pod description budget so that workflow where we are actually executing, it will remain in the system. It execute the test and it aggregate the test. And then it pushes the data to the S3 bucket. So these are the 4 steps we usually do as part of the workflow. Now, as part of the service account, when we are actually executing, it requires certain role and role binding. Those 3 things are actually given here. And this is the one which have the information that where and how we will go and hit the endpoint. So before I jump in, let me just start the test because I have given some context. So let me go, and I have kept this demo ready. So I can go and just go build now. This is what we talked, that someone like Jenkins need to initiate that. And we rely heavily on the declarative way of a pipeline. So I can go here, input. And here we put all the parameter, like how much load you want, how long you want, what's the study time, what's the ramp up time, how you want to configure the Keptn, which kind of load you want, anything and everything we go and we put it there. So here, these are the thing. And then I just enable the Keptn, and then I can go and proceed. So it will take 5 to 10 minutes time before.
And as you're figuring out your input data, it's amazing what you build, and this is all part of the DISTRO project, which means this is all stuff. I assume you will share your
demo gods.
Demo gods, yeah, that's what it is. In this case, I think it's not related to Keptn. It's Jenkins.
Yeah.
No, but thanks for sharing all this again while you're getting this build up and running. And I know it worked earlier because we went through this a couple of times in preparation of this. So I know.
No, it's actually started. I think there is a small bug which is causing the problem anyway.
Okay. I just tried to say to buy you some time.
No, actually it started. So now here you could see that this actually it triggered the load, and at it trigger the load, you see that we have done a submission of a Argo submit command. Mm-hmm. And behind the scene, the Argo submit will go and trigger the workflow. Mm-hmm. So this workflow has been started, as I mentioned, PDB create, and the run test started.
Can you zoom in a little bit? Can you zoom in a little bit? I know you have a big monitor, and here we go.
Sorry.
Thank you.
So now this is one of our Gatling tests, which is actually running. This Gatling test is a small CRUD operation for a given service where we go and create a specific resource, and then we go and manipulate that. So read is more about that getting that, and create is more about creating that resource. So this is a small hello world service, which is a kind of we are giving for all our onboarding team as a paid role. So let's go back. So now you could see that we already started this Jenkins, and this started triggering. It create first PDB pod description, and then it started executing the test. That's what I showed here, and it's visible and as part of this. So this test will run for a certain time. Mm-hmm. Now, and by the time we will finish, we'll probably have some result coming. So behind the scene, what will happen? You will get this kind of workflow where you can define your load generator dynamically. So here in the earlier case, I just define one workload distributor, but you can go and define that I need 1, 2, 3, 4, 5. The same time, you can also define that how you want your throughput. You want 1 TPS, 2 TPS, 3 TPS, or even 10 or 10,000 TPS. You can also define your ramp up and other stuff. So at the end, when you have all those things defined, the test will execute in a parallel. And then once everything is done, it will consolidate all the results in a S3 bucket. It aggregate that, and then it share that report to everyone so that we can visualize, because one of the biggest challenges is that if you distribute the load, how you aggregate. Gatling has a mechanism, as well as most of the programming tool on the performance have that aggregation mechanism. So we are leveraging and building on top of that.
A quick question here, Sumit. The TPS based goal. So if you say 1,000, 10,000 TPS, is this something that the distro is then taking care of? That means distro figures out how many load generator pods you actually need?
Yes. So behind the scene, what we do is that we will ask that you just tell the 10,000 TPS. Behind, we will take care that you need a 3 pods or 5 pods or 10 pods. We will distribute that. We know the capacity of each pod, how much it can handle. We know for a sure. And then based on that, and again, those all are configurable. So in your YAML, you go and configure that how you want the distribution to go, and it will give the aggregated result. So 10,000 TPS, it will distribute on 6, 1 TPS, one pod is there. And that's what you have seen here. Like when I just executed only 1 pod. So now here by this time, you have everything has been actually executed. You can look into the output of the artifact. You could see that run. Those who are familiar with the Gatling, they know that there is a simulation file has been generated, and you really need to combine those simulator files to get the aggregated report. So meanwhile, this part is happening. Let's go and see here. I have something. So it will come something like that. It will go and run the test, initialize the Keptn. It will make the Keptn quality gate call, post the event, and then it fetch that event and make the call, whether it's based on SLI and SLO, how things are going. So now this is a good segue to start, like why, when everything was working till that, everything was working. We were able to do the load testing, download the artifact, archive. Then comes why after that, what was missing. So what we found is that this is fine, but this is not end-to-end automation. We are able to get the Gatling report. We can still make some manipulation and say that, yeah, the response time is this or status is this, we can pass or fail. But our system is huge, right? We have everything dynamically. So it's end-to-end automation kind of stuff is missing. So someone need to validate, they still need to go and look into the Gatling report and say that, yeah, this is the thing. And then they need to go to the server side and say that, yeah, this response time is fine. So still some manual work is required. And then the other part is that the scale is very dynamic. So sometimes you need a 10 TPS, sometimes you need 10,000 TPS. So it is really important that how you can manipulate the scale. And then with the manual stuff, it becomes very challenging. There is no native way. We were running on the Jenkins and we were looking into that. There is no way we can go and look within the Kubernetes that we don't need any infrastructure, how we can go and get everything end to end. And as Jenkins is a shared infrastructure, we do see a lot of bottleneck, and then it's not 100% self-service. So you still have some manual work. So because you need to see that which kind of load, and you have different kind of performance testing. You have small performance testing, which is just a 1 hour. You have medium, which is a 4 hours. Then you have long one, which is a two days. How all those things become a dynamic. There comes the Keptn. So we found that Keptn has a SLI, SLO based information, and we already have very good clarity that what is our SLI for a 1 hour test or a 4 hour test or a 2 days test. So we, and again, one other thing which is very interesting for us, that we want the the load pattern to be very dynamic. So sometimes we wanted to run on a Kubernetes cluster on one specific service. Sometimes we want on a 10 different services. Sometimes we want on 50 different services. And there was a few scenarios which is rare, which we do for releases, that we need in one cluster 200 namespaces same time execution. So those are some very, very interesting challenge which is making everything a dynamic. Now on top of that, the other challenge is that the distribution timing is also changed, like small, medium, and low, heavy, and extra large kind of execution. So we opted for that, and here you could see that we onboarded all our services on a given cluster dynamically using a declarative pipeline. So we won't go one by one and onboarded that. Now the result is that you have the run coming, and then whichever run we are doing, we can have initialize the Keptn, get the quality, and get the result. Later point of time, we converted on top of what the Keptn team has created the declarative pipeline. We created our own pipeline and show the result. Now, why we pick Keptn? I think that's also an important aspect. So the automation. So now, when you go and execute, you don't have any interaction. It's a complete 100% automation. From starting to end, you just need to specify what kind of pattern you need. So here, if you could say that load type has been defined as a small. So this is small load type. I should be dynamically pick my SLI, SLO based on the small load, and I should be able to find that what is the end-to-end pass of this quality gate. Everything is a code. So if we want to modify, we just go and modify our SLAs based on SLI, SLO on the code, and then everything will remain. There is no manipulation required later point of time. We can handle the small, medium, high load. Vertical and horizontal, I talk about that one service, 10 services, 50 services, 200 services. Everything is in a declarative pipeline. I think that's a very important thing. Keptn has given declarative pipeline, and we are working only on the declarative pipeline. And I will show the code how this whole thing is working. And then everything is a pure road. So any team who onboard, what they need is a Jenkins pipeline. And in the Jenkins pipeline, we have those two libraries shared. And with those two libraries, everything is available. Behind the scene, we already defined the SLI, SLO. So what they need is that in case they need to change their SLI, SLO, they need to go and change the SLI, SLO. Rest everything will remain same. And how we have done, I think that's a teaser, is that like right now we are using one cluster. From one cluster, which is we have hosted the Keptn. Everyone go and interact with the context. This cluster, we have use ingress and route and endpoint. So we expose the bridge as well as the API. We use our Intuit Artifactory in place of taking from open source or the Docker. We download that in our Artifactory and use that image. Security and compliance so that we ensure that these images are compliant. Everything is being integrated to Jenkins, and I will talk in a while. And the self-service of SLI, SLO mainly for the load distribution and dynamic is there. So with that, let me just quickly show one part, which is that how this whole thing is happening. So this is one Jenkins pipeline we have. And here, if you could see that we have defined the Keptn library and we have our own library. So as part of this Keptn library, we do a lot of work, which is more towards that how we are running the, this is the input part, which you have seen that when
Sumit, sorry to interrupt you again. Can you zoom in a little bit? I know that you have really good eyes, but here we go. That's perfect. Thank you so much. That's good enough.
So this is the way how Keptn has been initialized. So we have defined our own function, initialize Keptn, which internally go and which call the actual which call the main function, which is the Keptn library. But prior to doing that, we have our own certain controls has been defined, and we use those controls. So like that, we have for chaos also the same thing. So Keptn, these are that main function we have written, and I will tell you why we have written our own function. So here you see that behind the scene, we will go and we'll make the actual call to the 3 core function of the library. So why we did this? We did this because we want everything to be self-service. So what do you mean by self-service? So we have defined all the configuration on one config file. So if I have 10 environment or I have 10 different services, what I need to go, I will go and define this parameter, which is telling that what I wanted to do. So I will go and say that I need number of pods, number of TPS, ramp up time. And there I say that all this parameter, what I need for the Keptn also being provided, that which project, which performance environment or stage I want, and load type equal to small. Now, my Jenkins library read this configuration, and then it invoke the Keptn library and provide all the parameter. So now to do all the setup for my distributed load testing, everything is available. And then I'm leveraging what we have for the Keptn. Now to distribute the load, we have created things dynamically. So we have created, there are 5 different configuration, and that's what I mentioned, that your SLAs are varying, right? So when you are doing 10,000 TPS, your response time validation is different for TP99 or TP95. And the same way, when you have a small scale, so here if you see that this is a small scale where I have defined that criteria is a little bit relaxed. But again, it's more stringent. But when it's the higher, the criteria is the throughput is pretty high. So that way, just with the throughput, you could see that for small load, I know that I have a 5,000 transaction is good enough. For heavier load, I need a 5 million transaction. So that way, I can just vary, and I don't need to go and change these things manually. I just keep those things, and through parameter, I can pass those values. So that's so once we run all this part, we go and we aggregate the results. So let's see, by the time, I think I'm hoping this test is done. Yeah. So this test is done. So let's go to this portal, which is 829. So I hope this is. So you could see that this is the complete heat map, and where we define that 95 percentile throughput, error rate, the percentile 50th, and all the other response times. So now, initially we had some hiccups. We do have some outlier, but now everything is kind of stable. Again, this is for demo, so things has to be stable. But on the real scenarios, these values change. And the moment we see that, we fail that, and the quality gate will say that this is a failure. So to show that, like how other way we can integrate, we have. So if you see that bridge Keptn, this is the place where we have actually hosted everything, and we have Swagger API also available. So if someone wanted to try it out, that they can go and execute that. This is the latest execution, and you will get a specific context, and on that specific context, you can go and make a call. And then here you will get the full information. Now, based on this information, which is coming from your SLI and SLO, you know what to, if there is a problem, what to work on. Otherwise, everything will go smooth. So this is the way, that's a demo. I talk about that. Now, in Intuit, we have all the data going to the wavefront. So we do have the app dynamics, we do have Dynatrace, but as we want everything to be in a single source, there is another work we started, though we are still not finished that. So we initially did with the wavefront integration. We wanted to make another SLI of wavefront and define all those SLI and SLOs and fetch that information. Litmus chaos is another thing which we started, and I'm glad that that is all. I think it's been finished, and we still need to take the latest one. We are we are not on the latest and greatest of Keptn. We are on 061, which is a pretty old one. So we need to do the upgrade. Now, overall distributed load testing, why we did that. Before doing that, I will just show that this is the project where how we are, or anyone wanted to use this distributed load testing on a Kubernetes, how they can do that. This has been shared, I think, to a couple of months back. And this is a blog I have written, which talks about that if someone wanted to start from scratch and wanted to do the distributed load testing in that, I briefly talk about that how all this integration works, how the Keptn works, as well as how Argo workflow and the Jenkins pipeline will go.
Sumit, can you do me a favor? These links, we should add them to the meeting notes.
It's added actually. Actually, I have added that in.
Perfect.
I think
that's okay. We'll figure. Yeah, we'll add it to the meeting notes of the user group meeting, because this is great.
Yeah. So this is a good starting point, and the biggest problem what we solve is mainly for the cost. I think cost is if you think about any of the performance tooling, the hosting cost and the licensing cost is pretty high, and based on your users, you can definitely optimize that. And then this is a more Kubernetes native way of implementation, and Keptn is also a CNCF project and being hosted in Kubernetes, so it become a smooth integration without thinking too much about that. Before I jump on, let's see, I think that's the latest one has come. Yeah. So the pipeline is. So again, all those things, again, it failed because I have a small bug where I'm not able to fetch again and again, because I'm on a pretty old version, and me and Andy was trying to fixing that, but we were not able to fix that. But here you could see that all this information about how the Keptn is invoking in the post event and then getting that event in a looping manner and then providing that information. Now, with that, this is another interesting thing. So now you have something available. So you can go and look for this test result. So you could see that this result has come, a Gatling result. We do have some information about the 95th percentile and that, but again, as I mentioned, that if you look for dynamic, if you look for everything on a different load, this 50th thing is being hard coded, right? So it cannot go, and then it will only look for the certain parameter which Gatling supports, right? Like it cannot go the CPU percentile. So if you say that my CPU percentile should not go above and beyond of 40% or a 70%, there is no way I can do that. So most of the things which is on the server side or SLI, SLO, which is above beyond client, you cannot have that. So we probably need something like getting what Keptn is providing.
And I think, as you said in your example, you're pulling the SLIs from Dynatrace in your case, because that is monitoring.
So we pull the data from two places, one from Dynatrace and the other one is a local Prometheus. As I mentioned that we are still mix of that. We want a single source of truth. So we wanted that to be wavefront integration, so that everything will be picked from the wavefront. And this is the test we actually executed.
Very
and cool. I think for performance, so these are the two calls which I mentioned, read and create. And these are the read and create calls.
Yeah. So you also have the test integration where the names of the test steps are passed over to Dynatrace. That also makes it easier. Cool.
Yes. I think this is something which we shared long back and last performance performed 2019. So, and we do have some handy stuff going about the chaos workflow. So now we are working on the workflows for the chaos also, and this also need to be integrated, because right now we run the perf test and then we can also run the chaos test. And this is the workflow we have. And then after that, we can still have chaos specific SLI, SLO defined, which we actually have that. So we do have chaos specific SLI, SLO, though I don't have a handy demo for that. So with that, I think we are open for a Q&A.
Yeah, I got a question for you. So first of all, thanks for this. I hope you will find soon time to upgrade Keptn to the latest version. I know you've just been traveling to India for the last couple of weeks and you have a lot of other things going on. But the great thing is with the latest version, you will, the heat map that we've seen, and you said, sometimes you get some messy data. One of the latest features in the heat map is that you can actually invalidate results. Yeah, I think that's going to be nice. And it's also needed because sometimes you just run tests that are just not great, and so there's a lot of new capabilities in the latest version. We should check it out.
Yeah. Meanwhile, I think one other thing which I probably have forgot is that I mentioned about the two setup, right? So here these are the the UI again. So here you could see that these are the services, and these all are the services which we actually onboarded. So here you could see that it's just the name and then everything will come onboarded.
Very cool. Yeah, that's a great way to see also that Keptn is used in these larger environments already with so many services onboarded, and you're doing a lot of work around here and integrating it with your pipelines. Also talking about performance, one of our engineers today just made a major breakthrough also on the performance of the Keptn UI when we query a large scale of data. So you will be very happy when you upgrade. One of the questions that came in is talking about SLIs and SLOs. You mentioned that you have different SLOs for your different workloads. Now, how do you have any best practice? Because I think people are struggling, at least the people that I talk with, they're struggling a lot in figuring out what are the best SLIs and SLOs. Is this something that where you say just go with the traditional red metrics, so response time, error rate, and throughput, and then you look at your monitoring data in production and figure out what it should be, or what's the best approach? What can you tell people?
Yeah, so I followed what Keptn is suggesting, but we do have certain SLA defined for our services. We follow three concepts. One is the error rate. We don't want anything which is beyond 0.01 as a error rate. We want our response time. Response time is something which we have actually nailed it down very clearly. So we define percentile 99, percentile 95, percentile 90, and percentile 50. So what that means is that we have 5 different levels of the response time validation. I think this is one of the needle mover for us with the status, and this we are actually ensuring that the load distribution is across the board. We don't see any outlier. Anytime we see anything major on the error, we should see that is it because of the infrastructure platform or a cloud side. So that actually help us a lot to figure it out but I think keeping SLI SLO for standard, that we have one standard for TP99 for this, is not varying, because based on the load and the type of test, it varies a lot.
Okay. Another thing that I would love to see, and again, this is something maybe we can work together in the future. I know you're currently using Jenkins to trigger your test, and then once the test is done, you trigger Keptn. Keptn itself orchestrates and automates processes. So actually it would be nice to see an integration where Keptn can actually take care of this process workflow, where Keptn can, for instance, also trigger DISTRO, and after DISTRO is done, it then automatically falls into the quality gate evaluation. So just a thought here, that would be great, right?
Yeah, we can definitely explore. Right now, this Jenkins, because this is a very Intuit way of execution, and we have a specific context being set so that we can do. Anything else requires some other compliance things which we have to go through.
Another question that just comes in from Arthur: are there any other parameters besides the load test size which influence your SLOs?
I think again, performance testing and performance execution are two, it's a vast thing. For our need, we were looking only for performance test. We were not, and we have a pretty clear distinction that we are looking only for study time and the ramp up time. So we want ramp up and the study. So this is a very important aspect for us. Now, if you have a different way of performance execution, you probably need to vary your SLI and SLO. For our use, we use only those two parameters and throughput, and based on that we define SLI, SLO. But for others, it definitely varies.
Okay. And in terms of the number of services, so you had a lot of services up there in the Keptn bridge. What is the difference of all of these? Like for each service is behaving differently, right? And that means your developers then, if they test service A, B, and C, do you educate them? Do you mentor them? Do you sit down with them to then define the SLOs that are good for their service based on these in different workloads? Or how does that work?
So this is mainly for our platform. So for our platform, what we have, we are creating our customer specific cluster behavior. So that means that in a cluster, you have 20 services or 30 services or 50 services, and each service will have a various workloads. So if I can show quickly about the workload, those workload. So this is, I just shared, this is just a one pipeline. Okay. Now, when we are running on multiple, we change these parameters. So if you see this parameter, let me show that. So if you see that the parameters, what we have defined, this is just for one service and one environment. Like that, you have various environments. So here, this is the environment. Here, there is a different environment. This is another different environment. So this is another environment. You see that. So now for one environment, it is going for 5 pods with the 1200 as a peak. For someone, it is a very small. For someone, it's pretty lame also. So like that's the way how we do the distribution. So we have various distribution. You put it in the config and then you do that. So again, as you have to define that what is your SLA, and then you put it in that. And based on that, you pick the load type is a large now. So now I will use for this one as a large SLI SLO compared to the other one where I use a small. So here in a QA, it's just a small one. For E2E, again, it's a small one. But if I go for perf or a different service, it might change.
Yeah, cool. All right, folks, if there's any more questions, let us know either through the chat or through the Q&A feature, the question and answer feature. Jürgen, is there anything else from your end?
Nope, I think there are a lot of positive on that. This actually helps us a lot. I think I don't have that one of the big execution where we actually executed 200 parallel load distributed tests. I think which actually created more than 50,000 TPS load across the board, and all those things we are able to validate via. So here, this is one big execution.
Yeah.
So it's a 40,000 TPS. 40,000 TPS on a given cluster is a pretty huge mark. And here, if you see that overall distribution of the load per pod is just 20 to 30 TPS. We reach to 900 plus nodes in this case. But this is one of the greatest result we were able to produce.
Pretty cool. And then Keptn in the end is automating the analysis of the data. That's awesome.
Yes.
Perfect. Cool.
Really cool.
Thank you so much. Jürgen, back to you.
Yeah, so thanks so much for sharing. I really think it's great content, and it's great what you built there. I just want to share, do I have my, yeah, I have this here again. I just want to briefly share and remind you again, if you have not added your name, I tried to add a couple of names that I saw in the participant list. If you want to add your name or your details, please do so. I will share the link to this document again in the chat. And also, if you have any ideas on future agenda items, if you want to comment on it. So I will allow also the microphone. So maybe in the last couple of minutes, we can just have a discussion if you want so. If you want to open up your mic, you don't have to. Yeah, it was the first time trying this format. So if you have any comments on this, if you like it, if you don't like it, just let us know. Also around the future agenda items. If you want to present something in our Keptn User Group, let us know. If you want to hear more about the topic that we suggested here, also let us know by just commenting on it, and then we can try to make it work to present to you these topics, and we can have discussions on this. Also, Sumit, if you have the link and if you're able to share it with the Keptn community, please paste it in here, the link to the slides. I've already added the blog. That would be cool. I think it's a really great, it was a great start here and a great format to get in touch with the broader community and to showcase what has been done with Keptn at Intuit, and I really love it. It's really great. Yeah, so if there are any questions, let us know in the chat. Yeah, perfect, thank you. And otherwise, we will let you know when we host the next Keptn User Group. We were thinking about doing this on a monthly cadence, probably on Tuesdays, but we will let you know in our Keptn Slack and also on the Twitter account that we have. And we were happy to see you there as well.
I really enjoyed it. Thanks for the very interesting talk, Sumit. And I think it's a really great format.
Thank you so much.
Are there any more questions for Sumit?
Likewise, I just want to add, it's a really tremendous and great work done by Argo team and Sumit. Amazing work.
Thank you.
Cool. Thanks, everyone. And we will let you know about our next edition of the Keptn User Group. Next time we have more time also for discussion and explanation of the use of Keptn. I have to mute Suhaib because it was he had a little bit of background noise. But for today, thanks everyone for joining. We do host our Keptn Develop meeting tomorrow, 5 p.m. Central European time. So basically the same time as today. If you're interested in building integrations with Keptn, if you're interested in the latest developments on Keptn, please join us tomorrow, 5 p.m. Central European time. And you will find all the links also on the Keptn community space on github.com/keptn/community. Congratulations again to the Triscon team on your community rockstar award, and thank you so much, Sumit, for presenting. It was really great work. And thanks also for doing the moderation for all the questions.
Yeah, you're welcome. And I am just posting the link to the YouTube channel because Elvis was just asking in the chat. So there's a Keptn YouTube channel, and I think the other great place to start is the Keptn community page on Git.
Absolutely. I will just share this again.
Yeah, and as for Brian becoming a member of the user group, this is all open. We will, we organize ourselves through Git here, and also we are on Twitter @Keptn Project. So follow us there, and you will see when we have new announcements, new events, and on the community page on Git, you also find the link to the Google Calendar, so you will see which events we have when.
And I would just share with the
that was cool.
Very interesting article that was also mentioning Argo CD plus Keptn. So I think it's a great fit for today as one of the 5 open source projects to watch in 2021. So maybe it's a nice read for the evening. And with that, thanks so much, everyone, and see you next time.
Yeah.
Yeah, thanks for having us.
Thank you too. Bye-bye.
Nice evening. Bye.